We're going to talk about how to write formulas for a chemical compound. So the first thing is to understand the difference between compounds and mixtures, which we talked about in a prior video. Remember that compounds are elements that are connected together through chemical bonds, and mixtures, on the other hand, is just two elements or two compounds, or it could be a compound and element that are mixed together. They're not connected through chemical bonds. Now, chemical bonds are very strong, so that connection is what separates what we call a compound versus a mixture. Okay, so the way you can imagine this is if you have two pieces of Lego. If you glue those two pieces together, then that's what we would consider compound, because the glue represents the chemical bonds. If we just put those two pieces in the same location, that would be considered mixture, because they can be easily separated because they're not glued together. So that's really the idea of compounds and mixtures. The picture here shows the difference also between mixtures and compounds. So mixture here, as you can see, is just the red sphere represents oxygen gas and the white ones represent hydrogen gas, and they're not connected to each other through chemical bonds. Here, on the other hand, hydrogen and oxygen is combining to form a compound. In this case, between the red sphere and the white sphere, they're stuck together. So they're glued together through the chemical bonds between oxygen and hydrogen. Now, a chemical formula is a formula for a compound. It's not a formula for a mixture. So to represent that compound, we have to list all the elements that are part of that compound. And the way we list them is we have to indicate the symbol of the element, and then we have to indicate how many of that element is there. And the way we indicate how many elements is we use a subscript. So, for example, if you have water, which has the chemical formula H2O, we would put H first, and then we follow by a subscript 2, and that 2 indicates that there's 2 hydrogens in H2O, followed by O, and there's nothing after O, indicating that there's only 1 oxygen in H2O. So 1 as a subscript is not included in a chemical formula. So there's a question of which element to write first. Why not write OH2, for example? The way we do this is we go with the elements that are more metallic first, followed by the elements that are less metallic. So in a prior video, we had talked about that in the periodic table, elements are organized as metals on the left side and nonmetals on the right side. And as you go from left to right, you get less and less metallic. So when you write formulas, you would write the elements that are closer to the left side first, followed by the elements that are closer to the right side. So for example, if you have NaCl, sodium chloride, you would not write it as ClNa because Na is to the left of Cl, so you would start with Na first, followed by Cl. Same thing with some of these other formulas here. So for example, CO2 and not O2C, and NO and not ON. Okay, so hopefully these are all easy to come up with if you have the periodic table in front of you and you can see which elements is to the right and which elements is to the left. Now, here's another thing that's important, which is that some elements, when they combine, they don't just combine to form these neutral species, right, which we can call molecules or ionic compounds. Sometimes these elements combine and they form something called a polyatomic ions. Poly here means many, so it's basically an ion that's formed by many atoms. In a previous video, we had talked about monoatomic ions like Na plus, for example, or Cl minus. Those are ions that are formed only by one type of atom. Here is polyatomic ions, means the ions are formed by many type and numbers of atoms. So an example of a polyatomic ion is NO3 minus. We know it's an ion because there's a charge that follows the formula. So NO3 is a group of atoms, right? They're combined together, and then when they're grouped together, they have a -1 charge. So it's an ion as well. So this polyatomic ions is formed in nature. We'll talk a little bit more about the type of bond that connects them, but they are formed in nature and you really have to memorize them. So what you're gonna need to do, and I'm gonna scroll down here, is go to this page in your notes, which is page 4, And you can see that there's a table that's titled Polyatomic Ions, and it says to memorize, and there is a list of these polyatomic ions that you want to memorize. So you want to know all of these polyatomic ions, their names and their formulas, because we're going to have to use this later on to make ionic compounds, right? So you want to make sure this is memorized as early as possible. Okay, so one thing about polyatomic ion before we move on to the chemical formulas is that you treat them as a group. So if you have, for example, that nitrate ion, it has a -1 charge. You want to combine that, for example, with magnesium, which has a +2 charge. Remember that to combine something into an ionic compound, you have to create a neutral charge in the end. In other words, the total charges when you combine them together has to equal 0. So to do that, since magnesium is +2 and each nitrate is -1, you're going to have 2 nitrates to balance out that +2 in the magnesium. And so when you do that, your formula would look like this: MgNO3 2. You put a parentheses because that whole group of nitrate has to be multiplied by 2. Remember that if you were to write this with, say, a monoatomic ion like chloride, for example, it will be just MgCl2. But in this case, the whole unit of NO3 is -1. So we put parentheses around it. All right.